Unit 6, Section 2, Similar Polygons. Now this section is really one of the main focuses of our whole unit, which is similar polygons. And in the previous section we talked all about ratios and proportions, and that will play into a lot of what we're talking about when we're talking about similarity. But first we're going to start with a review of what are congruent polygons, because that's what most of our experience is with. But they're very different if they're congruent or if they're similar. So congruent polygons, that was when we had exactly identical copies. And the notation we used for that was the equal sign with the squiggly mark over it to say, and that was to say that all the angles were equal and they all had equal sides. So whenever we had two congruent polygons, we said we knew all the angles needed to be the same between the two polygons and that the side lengths were the same. So that's very different from what it means to be what it means for polygons to be similar. Similar polygons are polygons with equal angles and proportional sides. So that means the sides don't necessarily have to be equal, but they're proportional, and you'll see exactly what that means here really soon. But the notation we use for that is just a squiggly mark, because it's not to say that everything is equal, but they are similar. You can also think about this as almost like if a shape is blown up to be bigger, it could still be proportional. Or if it's shrunken down into something smaller, but still has all the same angle measures, it could be similar, or the sides could be proportional. And a scale factor, which I've been alluding to earlier, is a ratio between side lengths of congruent polygons. And the notation we use for that is we use the variable k for a scale factor. And so we'll use that scale factor to solve for missing side lengths and to solve for x when we're given and we can find a ratio of similar polygons. So example 1 just asks us to simply look at some polygons and decide if they're similar or not. So if we look at these groups of polygons, and this isn't going to take much measuring or anything, it's just a little more obvious if anything. If I look at A, I see that there's a problem here in that the angle measures of this one and this one are definitely not the same. They just look like different shapes. One's a trapezoid and one looks like a rhombus or a kite or something. And this one looks like a parallelogram. These one look like they have right angles. So I can say that these are not similar, because I can see that they have different angles. For B, all of these look like they all have 90-degree angles, and all of their side lengths look like they are proportional. So they all look like they're squares, so I think they are all similar. So it doesn't matter if they're bigger or smaller, but as long as they look like they all have the same angle measures and proportional sides, then they can be similar. And C looks like they all have the same angle measures, and they all look like isosceles trapezoids, just with proportional side lengths. So I'd say that these are also similar. And that concludes video 1. In the next video, we'll look at some examples of different polygons and see what we can do when we know that they're similar.